Yay, wir können anfangen mit dem nächsten Talk. Es geht um die kleinen Dinge im Leben. Neben mir steht schon André Lampe, ein Laserphysiker.
Next to me standing is André Lampe, he's a laser physicist.
Vor allen Dingen beschäftigt er sich mit Mikroskopen.
Mainly he's worked with microscope last year at the 33C3. He has already given a talk about microscopes, which you can buy in your home. And that's why it's particularly cool that today we can talk about this again. And we can have a close look at what you can do yourself, so without having a proper laboratory. So thank you very much for being here. There you are. Thank you very much.
Ja, einen schönen guten Abend.
Welcome everyone. It's about the small things in life too. That's a prequel, not a Cha-Cha Binksy.
Mein Name ist André Lampe.
My name is André Lampe and I love microscopes really from the bottom of my heart. It's a very nice picture for me, which was based on for Kirschvogel. You can follow her on Twitter. Last year at the talk, I was talking about high-resolution microscopes. It was talking about mainly that at the limits of what's possible in research, you shouldn't be focused that you make pictures. It gets mainly the point is about the data which is behind these pictures, and that the raw data is particularly awesome because the software is developing more faster than the hardware which is lying behind. So with better software, we can have work at a resolution limit. That's for the professional scientists.
Ja, also so Menschen, die halt
so like people who are doing stuff in a lab, but if you're just a curious person, you're interested in nature, and you want to have a close look at the things around you,
dann ist das nicht zwangsläufig.
Then this is not necessarily the thing for you. Then it makes sense that you are actually looking with your eye on the thing you're looking at.
Tatsächlich Bilder.
And there's also things about pictures, and that's what I want to talk about tonight.
Wie man anfängt mit der
So the point is how you get started with microscopy. So if you're just curious, and I'm going to try to explain which parameters are the important ones, if you have in mind to take a few euros and invest, and already warning from things what you can find in stores or online, sometimes it's just bullshit. So before we are starting, some pictures of things we can look at with the microscope. So here it gets interesting if these things are strange. On the left-hand side, it's on the right-hand side, you see curry powder in a mid-range magnification, and you can already see this dust, which is just unicolor. In a magnification, you can actually see these different colors. Here at the very left-hand side, you have a needle. It's a tip of a needle. In the middle, it's such an injection needle from an insulin. On the right-hand side, it's a tip of a pen. Especially that tip in the middle, you can see how actually sharp it is compared to the thing on the left-hand side. On this picture, that's from another talk from the 33C3, from Chris Galinski. Thanks to you. And I can use your pictures. He was talking, how do I crack satellites and cable pay TV? He put much effort to clean the chips. So there's really much more behind that than microscopy. But in the end, using a microscope, he was able to look at these chips. And at the points where the data was saved, he was able to read this out. Right? You see the bright and the darkest. This is representing ones and zeros. Actually, that's something you can do with a microscope. Watch that talk, it was really fun for me. Biology, there are other things. On the left-hand side, you can see a video from a colleague, Martin Balasch. He's writing things for Skylogs. In his aquarium, he was looking what he finds. This is animal. You can see here on the left-hand side, which is moving around. On the right-hand side, there are many pictures, about 80 or 90. It's a sample for microscopy made from a fungus. You see the lamella It's upside down, if you're wondering about that. You see the lamella and the core and the inner cell structure.
Eine kurze Geschichte, wie ich dazu
A short introduction
auf unterschiedliche Arten mit Mikroskopie.
how I got into the topic of microscopes. I studied physics, laser physics to be accurate. Then I went to biochemistry.
Da war es dann so, kommst ins Labor, hast
Then you're getting into a lab. You start reading this microscope, and then the chef is there and says, "Cool, may I have a look?" And then you as a physicist say, I just worked on that 3 weeks. That just this part from the camera. What do you want to see? It doesn't make sense. So you were going to see colors, and the camera is black and white. So look at the data. That's the interesting thing. Damn it! It's so I said, but so I was new in the lab and stuff. But Jan, my boss, he was a cool dude. So if you see this, no hard feelings, sort of.
ja. Aber ich habe dann so, warum?
I was like, so, oh, why do you want to look through the microscope? I don't understand.
Ja, du musst ja auch mal ein bisschen was mit Biologie machen.
Yeah, so I should do something about biology. So you look at the cell structures. So I had my own cell line, and I had to manage this. And they told me, colleagues told me, okay, listen, you have this pink liquid. If you want to get this sensor, you take 1 milliliter and put that on top. If this liquid is a little older, then you take a little bit more. And I said, what? What does this mean? What does it mean? It's a little bit older, you take a little bit more. I'm a physicist.
Die ist deterministisch.
This is deterministic.
Etwas passiert
A, something happens, B.
in der Biologie.
In biology, you have A. Something.
Nicht deterministisch beschreiben.
We can't describe life in a deterministic way.
Das ist kein Fehler der Biologie.
This is not biology's fault. We've just not gotten that far to understand this complex device that is life. We can't understand every single step.
Das ist etwas, was der Biologie innewohnt, wie das deterministische,
This is just a part of biology like determinism is to physics.
das Klick gemacht hat. Das hat aber ein bisschen
And that's what made a click noise in my head.
Biologie ist
This whole, well, use a bit more.
die richtigen
Biology is like baking.
Inhaltsstoffe
You need the right ingredients,
dafür.
but you also need feeling. Is the dough too dry, too wet? Do you need to put something in there?
Bilder machen.
And you don't have to take pictures of every single thing. Maybe you just have to look at it and use your own eyes and get a feeling for it.
Das ist tatsächlich wichtig. Und am Anfang
That's actually important.
meine
In
Kollegen
the beginning, I said I'm going to go into the lab, make my measurement, and my colleagues said they take pictures. Right now, I'm measuring and taking pictures. And I'd like to live in a world where a physicist, a biologist, a pedagogue, and a sociologist could go out drinking and respect each other and not hate on each other for their profession. But that's probably going to take a while.
Was ich eigentlich sagen wollte,
What I actually wanted to say, microscopes.
geben, warum es wichtig
I'm going to give you a little introduction why it's important to look through them. But we also want to put a focus on how to get pictures out of them. There's different types. To the left, a stereo microscope. The sample is relatively far away. You can put it in a little petri dish.
Tuben drauf,
And you generally have 2 oculars to look through.
ernst gemeint. Da ist ein kleiner
That's because it's actually a stereo microscope.
ein dreidimensionaler
The eyepieces are angled to each other so you can see 3D, but no high magnifications.
Blatt oder
At least you can put big things under it, like a beetle, a leaf, piece of dirt. What do you want?
ich nenne es immer gerne normales Mikroskop, aber
Then there are normal or through light microscopes.
meines Lebens irgendwie ständig.
That's the kind of thing that I've sat in front of for 7 years. So that's probably why I think it's normal.
Darüber geht es zum größten Teil.
That's the main type. Then there are a few others. I'll mention them here and there, recommend some,
Ein paar davon ein wenig verdammen und euch davon
and maybe hate on a few of them and warn you.
Lösungsmikroskopen. Das
And there's the fluorescence high-resolution microscope. That's not a topic today, but I just wanted to show it to you to see that it's quite a bit more complex.
aber bevor wir uns jetzt mit
So that's the types.
der Vergrößerung beschäftigen,
And now, before we get to magnification,
liefern, weil ich habe nämlich nirgendwo einen vernünftigen Maßstab gefunden, mit
I wanted to show you
irgendeiner Form abschätzen.
Or I want to demonstrate to you the relative sizes of things.
Habe ich genug Public Domain Bilder,
So I sat down and looked for lots of public domain images
was nehmen kann.
to give you a sense of scale.
Fangen wir also bei etwas
And I think I was kind of successful, so let's start with something we know.
erstmal 1 Meter, Hund,
So, a dog,
Vogel,
a songbird,
Chip,
a computer chip,
ein Floh,
a flea,
ein menschliches Haar und
a
mit
human hair.
der Durchmesser gemeint,
The 100 micrometers mean the diameter. Pollen, bacteria, these are salmonella,
ein Virus.
a virus, this is influenza.
10 Nanometer sind Nanostrukturen auf
10 nanometers are nanostructures on computer chips. And to the right,
eine DNA unter
a
Elektronik.
DNA molecule under an electron microscope.
1 Nanometer.
And finally, 0.1 nanometers. Those balls are single gold atoms, taken with a raster force microscope.
So grob eingeführt habe, mal da drunter legen.
And if we put the microscope types, I told you about 100.
Das sein, ja, aber 10
The
Zentimeter.
stereo microscope is from 10-ish centimeters
100 Mikrometer.
to 100 micrometers, maybe a bit more,
Da wird man dann auch schon ein bisschen Geld
but
los.
it's gonna cost you a bit of money. Then there's the transmissive microscope.
Kann aber
Starts smaller,
runter als ein
but can go down even farther, a bit more than a micrometer.
eingefärbt.
I colored that part orange. We're gonna do that later. Then there's the high resolution fluorescence microscope. It goes down to about nanometer with light. And then there's the electron microscope
Mikroskop zurückgreifen. Diese eingefärbten
that
Bereiche,
goes down even lower.
das macht echt Arbeit.
The colored parts are really hard to do. That doesn't mean you have to invest a lot of time, but
Also muss man diese
for example, with the transmissive microscope, the samples are so thin that you have hardly any contrast at all. So you have to dye them, have to get chemicals, learn it. It might be a bit toxic, or you need a fume hood or stuff like that. That's what I mean with it's hard.
warum das viel Arbeit macht, das ist ja schon erzählt.
And about the fluorescence microscope, I told you why that is hard last year.
Bis 124
And now magnification, or what this 1x to 1024x actually means. You calculate that relatively easily.
das, was da an Vergrößerung
Eyepiece times objective is magnification.
so wie es da vorne auch steht. Ist ja sogar dasselbe. Und in diesem Fall, das
And in this case, the eyepiece is 10x,
habe ich da jetzt gerade mal hervorgehoben, das 8
the objective is 8x, 10 times 8, that's 80x.
80-fach zu was?
80x what?
Habt ihr euch das
Relative to what? Have you asked that yourself that?
größer als 25
It means 80 times larger than if it was 25 centimeters away from your eye.
wenn man das liest?
So that's hard to understand.
Weil
But
Pappröhre im Inneren einer
the cardboard tube inside a kitchen, a roll of paper towels for the kitchen, is about 25 centimeters long.
Vergrößerung denn tatsächlich
So that's a pretty good way to set the distance and see what this magnification means.
einen halben Meter weggeht, also 50 Zentimeter,
So if you go farther away to 50 centimeters,
bastelt was 0,5
you've built something that has 0.5x magnification.
beim Auge, wenn man durchguckt. Und
This is actually only useful with the eye if you look through it and not for pictures and cameras.
steht das hier in 400-facher Vergrößerung, könnt ihr
Every time you see a picture from under a microscope with the 400x, I could explode. They should put a little bar in there, a length standard, so you can compare that.
wenn man mit dem Auge durchguckt.
So you see, magnification is only relative to your eye.
Verstanden habt, super. Ein weiterer Parameter, den man im Kopf haben muss, wenn
Another aspect is the working distance.
man eine geringe Vergrößerung hat,
If you have a low magnification, for example, a 4x objective to the left here, then you can put it relatively far from the sample.
Vergrößerung will,
if you want a higher magnification, the objective needs to get closer to the sample. This kind of helps you to see how big is your size, or how do I have to prepare it. At 40x or higher, you have to get very, very close, and the samples then have to be put under glass, cut apart, and if there's an inaccessible place, it's hard, and I really have to look at the working distance. And this is how it looks with the digital to image. It's not the magnification in the top right. This is just the objective I used. With the 4x objective, the image looks like the one to the left. For the larger 10x, it's like the one in the middle. For details of the single cells, you have to go to 40x, the one to the right. And here you can see that at the edge of the image, it's slightly blurry. That's not because it's at the edge, but because the sample is a little wavy and closer to the objective. So we have to talk about depth of field. The higher the magnification, the closer you have to go, and the more problematic depth of field is. What this means is that with 4x, I found a piece of the sample that had dust on it, and I took an image with the 4x objective. With the 10x, it starts to blur. With the 40x, it's just a dark shadow. So the higher my magnification, the closer I have to go, and the lower my depth of field is. Okay. Magnification, working distance, and depth of field is everything you need to know for the beginning. So just so you've heard it, numerical aperture, tubus length, optimal glass thickness, and immersion objective. Larger magnification objectives are optimized for a certain thickness of cover slip. With immersion objectives, you put a drop of water or oil in there to collect more light. But for the beginning, this is not really relevant. But what's really rare to find on the package is the field of view. You can't really measure this or express this in a number. You have to see it. Here I showed it. I took 4 microscopes. The left, a Cosmos microscope for children. In the middle, a Bresser microscope for use in schools, about 130 euros. And to the right, an Olympus research microscope that's in the 4-digit range. And here you can see different, same magnification, but a different field of view. And I did this by holding a cell phone in front of the ocular.
So you can see the difference if you look just by. If you use the Cosmos microscope, it's a small tube. Bresser is a little bit wider. On Olympus, you already have a bright field of view. That does not mean that the Cosmos microscope is a bad one. It's really taking good pictures. You can work with that. But you're not talking about the field of view. And here I have compared different types of microscopes. Usually it's the case, a bigger field of view, it's the part where it gets expensive. So let's talk about the parameter bullshit. I showed you a different kind of microscopes. I looked at them online. I tried them. So 6 or 7. I collected the highlights. Magnification 40x to 2000x. Unfortunately, the resolution limit tells you that a magnification over 1250 does not make sense anymore. It's marketing. Cameras. If there's also a camera within, you have 2 megapixels, 5 megapixels, high resolution, blah blah stuff. All the products I had, it was just 640 by 480 sensors. I'm just telling you. Sometimes it was written there, but usually not. Camera, 30 FPS, 60 FPS, high speed. Yes, testing, it turned out, was software, easy to install, many features, sounds cool. By 5 out of 7 the things I've ordered were not software included. But in principle, they were right. The lenses, high quality optical glass, probably was just plastic. That's not too bad, because the pictures I showed you in the beginning from the needles, from the curry, everything was taken with a plastic lens. If this is a usable plastic and it's polished well, you do not need high quality optical glass. You do not see the difference. Not even in a lab you see the difference. If you are using plastic or glass, it doesn't matter that much. But I would have to say, warn you, this thing, you see here a smartphone where you have clipped on a microscope, which then is using the smartphone camera. One of our colleagues has tried that at assembly, and it turned out he does not have 4 ends. You have to hold the smartphone, you have to have the sample, you have to turn these little wheels to get the sharpness. And we have also talked about the sharpness and depth. I would say it's something 100, 200 micrometers. If you really are managing this, handling this, turning the wheels, having a sample, or only moving this 100 micrometers, respect. Your coffee level was actually, it's only 1 minute. I warned from that. I tried that out. They are completely bullshit. It's a pity, because microscopy is something very cool. Then you buy this and you think, oh, come, that doesn't work. Then you stop doing microscopy. So please do not stop doing microscopy if you have bought one of them. So better things with a camera and an LCD display. It's cool. If the camera is broken, or it's only 640 by 480, and the LCD is also stupid, you have spent loads of money and they're pretty expensive. Here you have the 2000 digital zoom. Yeah, great. And then the camera does it, and then you only see smeared out pixels, and you cannot really measure something. What I would recommend to you, I have tested all by myself, and I would never recommend something I haven't tested myself, and which is not using open source software. If you have different experience, here we have a microscope for pupils from the Cosmos. I didn't get any money from Cosmos. I've just used it. Yeah, it was just lying around, and that's why I do have this. Probably there are also other producers. So you just use your smartphone and take the pictures. It's the best camera is actually always in your pocket, and all 2 years something, you get a new one. You can actually take brilliant pictures and look at them. You can show them to your friends. It's just simply brilliant. And it's incredibly more pixels. Another nice thing is this funny thingy. You can actually attach your smartphone to that. It has the correct distance. You can take the picture. So yeah, you have there your microscope with a display and a camera, and you can actually exchange the things. I would actually recommend this one. It's very cheap, and you can do interesting stuff and digital pictures. Maybe we have a different type of microscope, such an old one. I think it's about 70 years old. And then I've just bought an ocular camera. I put that on the top. The cool thing is, microscopic technology, it's normed. So all the tubes have the same radius in the inside. So this ocular camera does actually fit. I just plug it in. It has a sensor in it, full HD. You can use it with open source software. So you can just a USB camera, you can use it with everything. It takes good pictures. It costs about 60 euros, if I'm not mistaken. But you can also do it with a pupil microscope.
Then there are these cheap, and I mean cheap, USB microscopes. You can't look through them, that's bad. But under 20 bucks, yeah, why not? I use this, something like this, to take the pictures of the curry powder and the needles. It's not bad for a bit of playing around, but please, you need to have some sort of stand for it, because holding it in your hand is going to screw with your depth of field and your distance. You're not going to be happy with that, because you can't hold your hand that steady. And what I can recommend, did it last year, Micromanager, the open source microscopy software. It can talk to all the cameras I've gotten ever, has a full Arduino support, so a really good project. Build your own motorized microscope. It's a really fun project. I'm just saying, So, about what? Thanks to Munich for the awesome stickers. I've got them from your box, and I didn't really say thanks for that. So, yeah, they're awesome. It's on my Olympus microscope now. So, concrete applications. We have, that is we, Anna Müllner and myself. She had a few agar plates. And what you see here is the result of a fingerprint from day one that grew until this afternoon. What you see there are bacterial cultures. So wash your damn hands. Really. We mean it. So I made a microscopic image of this, or rather 140, and clustered them together. And now I have a little scale bar in the top right, so you can see that. Thanks to Anna or Adora Bell. Follow her on Twitter, visit her website. Well, a fingerprint, 2 days on a petri dish. And I'm going to try to do this in full size so you can download it. Just look at my blog. That was it. I hope this was a good introduction. Come here and come to me and look through microscopes. I'm going to sit at the Science Hack and Communication Assembly next to the Chaos Patin. There will be links, there will be stuff, something, and most of it will be public domain on my blog. And I'm going to upload a lot of other things that happened here. And a bit of self-advertisement. I did science documentation. 3 scientists go into a bar and suddenly knowledge. Thanks for listening. Thank you for listening to Es sind die kleinen Dinge im Leben 2, translated by Duckman and...
2 Minuten für Fragen, das heißt eine ganz kurze, wenn ihr schnell zum Mikro rennt, können wir noch...
disregard that. Questions.
Wenn du eine Okularkamera einführst, dann hast du in dem Moment ja nicht mehr die...
If you insert an ocular camera, you lose the magnification of the old eyepiece. Can the camera compensate for that, or are there other tricks to get back to the original magnification?
Wenn du irgendwas als in das optische...
Well, if you stick a camera into the optical system, then it's about the pixel size of your sensor. And with my camera, it's 12 micrometers, so it's a very good camera. If the ocular is missing, you can actually add a reduction lens because the pixels of modern chips are so damn small. It goes down to 6 micrometers, and you can make really cool images with it.
Eine Frage können wir dann noch auf Mikrofon 2 nochmal.
We have another question from microphone 2. It's just a question, but more a remark I wanted to say. Cameras actually have pixels for a half a micrometer. These are 3 or 4 megapixel cameras, or like a quarter sensor chip. And you can actually combine them with, I thought that in a lab. You just take an acromate. You do not need a tubeless lens. You just take just a regular acrometer, and you can just illuminate that, and it takes good pictures. And you can just use actually very cheap Olympus objectives for like 50 euros, and you get really good resolutions. Just on the side there, acromate, that's an objective which is corrected that you do not have a chromatic aperture. Like this funny things in shifts in wavelengths that you get a rainbow or something in the picture. But I've actually never thought about it. That's a good idea. Cool.
Perfekt. Dankeschön.